Sadir is an international computer science student at UCL. Before coming here, he needed to prove the validity and the authenticity of his high school certificate. Hence, the signatures of many different parties, including ministries in Lebanon, his home country, as well as the British Embassy, were needed. And this was time and money consuming, since notarization and legalization is quite expensive. Sadir is not the only one who faces such types of problems, and luckily enough, a new tool called Blockdocs reduces the length of the chains of signatures needed by building trust between the document issuer and the document receiver without the need of any third party. This disintermediation was allowed by the use of the blockchain technology. Our main requirements are having two user interfaces, one for regular users, where they can upload documents and ask institutions to sign them, and another user interface, where verified and predetermined institutions can view documents, then sign them as a way to prove their authenticity. We are going to explore the system architecture while trying to see how it is set up. The first step would be creating a test RPC network, similar to a local blockchain network. This creates a set of public and private keys, which we can use to make transactions on the blockchain. Later, we pass on to compiling our smart contract, the piece of code that will lie in the blockchain. It holds a hash map, from documents to signatures on them, and functions to interact with the smart contract. Later on, we build the smart contract before passing to actually migrating it, which means that we deploy it on the test RPC. This deployment can be seen as a set of transactions on test RPC, each having an address. The next step would be linking our code to the test RPC. To do so, we use an API, Web3.js, which takes two parameters, the ABI of the smart contract, its application binary interface, and its address on test RPC. To get the address, we use truffle console, copy and paste the value in the PC address field. Later on, we pass to getting the ABI, and again, we copy and paste the value to the required field. The final step will be launching the Meteor server thanks to the Meteor command. This links our project to the different packages and libraries we've used. This also starts MongoDB, the non-relational database we've used for user authentication, to save documents information, and to manage the signature requests. Once this is done, we can see that the app is up and running on localhost 3000. The homepage provides some assistance on the services provided by the app. The next step would be signing up. Only regular users can sign up, while institutions would need to contact us directly so that we validate their authenticity. When the sign up is done, we reach the Manage Your Documents portal. On this portal, users can upload their documents and view them if they click on them. They can also request signatures from pre-specified institutions. We're gonna take the example of UCL in this situation. We are also going to ask for a signature of another institution to see how two signatures work at the same time. Please note that the signature requests are saved in our MongoDB database, and nothing has happened yet on the blockchain except for creating the reference to the document. Now we're going to go into incognito mode so that we can have different user sessions. Now we are going to sign in with the credentials of the Lebanese Embassy. We can see the list of the documents that are to sign, and they correspond to the request that was actually done. After viewing the document by simply clicking on the icon, the institution can either delete the request or sign the document, and the signature would be immediately visible to the user. Signing a document is actually a transaction on test RPC, which triggers some of the smart contracts functions. It consists in adding the public key of the institution as a signatory to the document. From the homepage, every user, even without signing in, can check the authenticity of a document by uploading it and seeing the parties who have signed it. A key decision we've made to solve the problem of the potential very slow connection with the blockchain is that users in their tables view the signatures as they are in our database and not from the blockchain. Hence, any error which happens in the front end won't affect the blockchain. It is kept separated as a very secure and private database, which can be accessed by the Verify Document tab. After meeting all our key requirements, and after doing successful unit, integration, and user acceptance testing, our future work will include deploying the app on a true blockchain network, which is quite challenging because we need to integrate payment and support slow connections. Thanks for watching.